Welcome back. We're at it again. Can you believe that it's been 10 practice exams? Can you believe it? 50 questions at the end of this one that you will have answered with me if you've gone through them all. Where we go through and we try to answer questions. We go in depth with it. I feel like we've come a long way since our very first one. I feel like the questions are getting a little bit better. I feel like the format's a little bit better too. We're trying to get more into those PBQs. Starting off easy and then progressively working towards those harder questions. That's our goal today. Let's get into it. Let's get right into it. Let's start with question number 1, shall we? All right, question number 1. Which protocol is used to automatically assign IP addresses to devices on a network? Starting off easy this time. Starting a little bit easy with this one. I know you've got this one. I know you've got it. You've got it. You're probably thinking to yourself, I thought Professor Kindred was going to challenge me. I thought that's what we were going to do. No. I'm going to throw acronyms at you, though. See if you can't remember those acronyms. All right. If you need more time, go ahead and pause the video. Remember, this is one of those questions that if you don't know, if you don't remember the acronyms, I would encourage you to flag it. Guess and then flag it. Because the acronyms really come into play with Network Plus. They come in with any CompTIA exam, but they really kind of, I think, are the hardest in Network Plus because it's usually one of the first exams that most people take. But let's see if we can answer this one. Which protocol is used to automatically assign IP addresses to devices on a network? I think we know it's not SMMP. SMMP is used to trap information. We often call it an SMMP trap. But I think we know it's not D. I think we know it's not Simple Network Management Protocol. Obviously, for managing the system, we can use SMMP traps to send alerts to a specific system. It has a wide variety of things that we can do with SMMP, but definitely not assigning IP addresses. Definitely not assigning IP addresses. I think we get rid of C, File Transfer Protocol, obviously to transfer files between one system to another. That leaves DNS or DHCP. If you guessed A, DNS, I'm afraid you'd be incorrect. Domain name systems. That's that telephone book where we match IP addresses to the actual name. That would be Amazon.com. We know that opens up to a specific IP address. That's where the DNS comes into play. So Dynamic Host Configuration Protocol, DHCP, that's going to be our correct answer. DHCP automatically assigns IP addresses to devices on the network. We can do dynamic or we can do static. When we do dynamic, we're doing DHCP. That's going to be our answer right there. There you have it. There you go, right there. All right, moving on. Question number 2. What is the purpose of a VLAN in a network environment? What is the purpose of a VLAN in that LAN network? Man, I cannot talk this morning. I need to stop doing videos first thing in the morning. I think I need to wait till the evening. But what is the purpose of a VLAN? A little bit harder. What do you think about this one? What do you think? All right, remember, 30 to 45 seconds. We want to spend no more than an absolute maximum of a minute. We want to read the question. We want to read the answer. Read the question. What is the question actually asking me? And then answer the question. That's how we want to go through this, right? We don't want to get through and just bomb rush it. A lot of mistakes happen on Network Plus and on other certification exams when we go through and just try to speed through it. Okay, we got to take our time, but not too much time. There's that careful balance. I would tell you that most CompTIA exams are as much about time management as they are about knowing the questions. Right? Let's answer this one. If you need more time, of course, pause the video. All right, what is the purpose of a VLAN in a network environment? I think we can get rid of encryption. We can get rid of D. To encrypt data between devices. No, that's not VLAN. It's not a VLAN. What about to translate private IP addresses to public IP addresses? We would call that NAT, Network Address Translation. Does that. That's C. So that leaves us A or B. I think we know that a VLAN does not extend the wireless signal range, right? That would be a repeater. That would be an access point. That could be several different items, but definitely not a VLAN. A VLAN is used to create separate broadcast domains within a switch. It provides us a little bit of network segmentation between it, a little bit of security within that environment. Cool things with VLANs, right? So B is going to be our correct answer. B is our correct answer on that one. There we go. All right, question number 3. Let's see if we can't make it a little bit more difficult on this one. An administrator troubleshoots a network issue and uses the ping command to test connectivity to a remote host. If the response shows request timed out, what could be a possible reason? What could be a possible reason for that request timed out? What do you think? I think this gets into a little bit of knowledge. And I told you we're going to get a little bit more difficult, a little bit more on the difficulty scale as we go through. What do you think? All right. All right. If you need more time, go ahead and pause this video. We're going to answer this one. I know I'm trying to go quicker. Through these, right? Administrator troubleshoots a network issue and uses the ping command to test connectivity to a remote host. If the response shows request timed out, what could be a possible reason? I feel like we can get rid of the DNS server being down. I feel like the DNS server being down is it's a decent answer, but definitely not a proper answer. Request timeout versus DNS server, not a real thing, right? I think that would be misnomer. So B, off the table. I feel like we could get rid of C. The router has failed. I feel like if the router had failed, we wouldn't get anything back. Right? Well, we'd get an error, right? But we wouldn't have even access into that aspect, right? And so I don't feel like that would be a good answer either. That leaves A or D. Remote host is unreachable due to network congestion, or the remote host is actively blocking ICMP packages. If you guessed D, you would be correct. Right? Not always blocking. Sometimes we ignore them, right? But we're not responding to them. We're blocking it up. We're not doing anything with it, right? This usually occurs when the firewall between the source or the destination is set to block or it's set to ignore, and it just doesn't respond. It doesn't provide that feedback into it. That's usually where we see request timed out, right? We're not doing anything with it. And so the system says, I'm not going to respond to that. That's where we see the remote host right there, actively blocking ICP packages. All right, question number 4. A network engineer configures a new switch in a large enterprise network that segments traffic using multiple VLANs. The engineer needs to ensure that VLAN traffic is properly routed between different VLANs without compromising network security. The network already uses a layer 3 switch for inter-VLAN routing. Which of the following configurations should the engineer prioritize to achieve this goal? What do you think? A little bit more difficult on this one, right? We're trying to get into the position of really starting to understand the different processes within networking. I told you we were going to get more difficult. What do you think? What do you think on this one? Remember, we want to read the entire question. And then read the possible answers, and then reread what is the question actually asking me. Not what I think the question's asking me. What is the question actually asking me? And then go through it. This one being a little bit larger is probably worth a little bit more points on your exam. Probably going to take a little bit more time. And that's fine, because we spent 30 to 45 seconds on those easier questions. We now have time to provide a little bit more in depth into these bigger questions, which are worth more points. Remember, time management is always against us when we're taking these type of certification exams. So we need to utilize our time the best way possible, and that's understanding easier questions, less time, right? Harder questions, we get a little bit more time. But if we're approaching that minute mark, maybe we need to guess, maybe we need to flag it and come back to it at the end of the exam. Maybe that's something we need to do. All right. Let's answer this one. Go ahead and pause the video if you need more time. A network engineer configures a new switch in a large enterprise network that segments traffic using multiple VLANs. The engineer needs to ensure that VLAN traffic is properly routed between different VLANs without compromising network security. The network already uses a layer 3 switch for inter-VLAN routing. Which of the following configurations should the engineer prioritize to achieve this goal? I think the first thing we need to identify is what goal are we referring to, right? And I think that it's got it right here. The engineer needs to ensure the VLAN traffic is properly routed between different VLANs without compromising network security. That's the goal. The rest of this is all fluff. It's all fluff. So what is the goal? Once we've identified the goal, let's answer the question, right? Okay, let's start with A. Enable IP routing on a new switch and assign IP addresses to each VLAN interface. That really doesn't make sense, right? Because we're already using a layer 3 switch for inter-VLAN routing. It doesn't make sense that we would go in there and then start using IP routing on a new switch and assign new IP addresses to each VLAN interface. That doesn't really make sense to what we're trying to accomplish, right? that would be a lot more time consuming. We'd have to go in through all of our other switches and start reassigning IP addresses. Not something we would do in a real network, unless it came down through its own project. So I feel like A is an easy one to get rid of right off the bat, right? Okay, configure 802.1q trunking on all uplink ports connecting to the layer 3 switch. While it is essential for passing VLAN traffic, it doesn't directly address our security issue. It doesn't address our segmentation issue. It doesn't address what we're trying to achieve, which is the goal, right? Without compromising network security, which means that it's a good answer. It's not a bad answer, but it has nothing to do with security, right? In this aspect of it. So definitely something I would think about. Definitely, I mean, it's on my list, but it doesn't really make sense since we have a layer 3 switch for inter VLAN routing already, right? And so definitely not something I would. It's not at the top of my list. Let's put it that way. It's not at the top of my list. Okay. All right, that leaves us C and D. C, implement private VLANs to isolate certain segments while allowing selective routing. And then D, use static routes on layer 3 switch to control traffic between VLANs. So using static routing, right? Using static routing, while it controls the flow of traffic, right? It doesn't provide isolation that a VLAN offers, right? So the static routing on the layer 3 switch to control traffic doesn't really make sense from a security perspective, right? It really doesn't provide us that isolation. With C, if I want to isolate devices or groups of different devices on my VLAN, right? Then I can do that by implementing those private VLANs, right? And so I can segment those off, and then with the selective routing, right, I can route to other VLANs on my network. And so out of all of these, right, I mean, B is a good answer. It really is. But I feel like C is the better answer on this one. So we want to implement private VLANs. We want to segment. We want to isolate different devices on our network, right? And then by providing that selective routing, we can interconnect between the different VLANs across our network. This really does meet our goal. I hope that makes sense. But question 4, gonna be C. There you go. All right, moving on. Last question for the night. Hardest question, I think, for some people. You were asked to troubleshoot a network issue where certain users are experiencing intermittent connectivity problems. You run the ipfig command on a user's workstation and receive the following output. Based on the output, what is the most likely cause of the connectivity issue? And what is your next step? What do you think? I'll give you a second to answer this one. Pay attention. What is the log telling us? What's going on here? This is a question where just understanding networking to be able to answer this question. This isn't an overly hard question. I would actually say that the question 4 was probably harder, but it does provide us a tool output, right? It does provide us that way of doing things. And so a little bit of different way of doing things. Providing a tool output, kind of going into the process and saying, hey, this is where we're coming in. Okay? All right, if you need more time, go ahead and pause the video. Let's dig into this one, all right? You're asked to troubleshoot a network issue where certain users are experiencing intermittent connectivity problems. You run the ipconfig command on a user's workstation, receive the following output. Based on the output, what is the most likely cause of the connectivity issue, and what is the next step? All right. It says there is no default gateway. Configure the default gateway manually. Obviously, there's no default gateway, but is that going to cause us issues? It's a possible. I don't think it's the best one. But it is possible, right? C, the subnet mask is incorrect. Adjust the subnet mask to 255.255.255.0. That necessarily is not a bad subnet mask, right? That just means it's 255.255, meaning it's a Class B network. We have the last 2 available. Meaning the CIDR for this is, for the last 2 IP addresses, completely versatile inside of our inner network. While most subnet masks are 255.255.255, in this case, 255.255.0.0 is perfectly acceptable. It's perfectly acceptable. Not going to cause any connectivity issues. Then we have B. The DNS server is unreachable. Configure the DNS settings manually. I don't think B makes any sense. There is nothing on here that identify the DNS server. There's nothing on here for DNS settings. There's nothing in this log that points to DNS whatsoever. And then we have A. The workstation has been assigned a PIPA address. Check the DHCP server for availability. And so it really comes down to A. And if we know what a PIPA is, right? If we know what a PIPA is, then we know that the IP address 169.254.1.15 is a public IP address, not a private IP address. And that would definitely cause our issues, 100%. And so that is going to be our best answer, where we have IPv4 address operating on a public IP address instead of a private IP address, which it shouldn't be on. Because remember, our private IP addresses are 192.168, and then those last two octets. We have 172.116, or excuse me, .16 through .31, and then the last two octets. And then we have 10 and the last three octets. And so those are private IP addresses. This is very much a public IP address. The answer is going to be A. The answer is 100% going to be A with that, right? And so there we have it. All right, I hope this was helpful. I hope it was helpful. We'll see you next time. I'm Dr. K.